Here we have the not isomorphic theorem. Two graphs G and H are not isomorphic if any one of the following conditions is true. And one or more could be true, and they're not isomorphic. Okay, so the first one is G and H have a different number of vertices. The second one, G and H have a different number of edges. 3, G and H have a different degree sequence. 4, G and H have cycles of different lengths. 5, G and H do not have the same number of connected components. Now, one misconception that students often make is they think, well, if each of these are false, then they must be isomorphic, and that's not true. It's possible to create a graph it's possible to create two graphs that have the same number of vertices, the same number of edges, the same degree sequence, cycles of all the same lengths, and the same number of connected components that are not isomorphic. Okay, so these are just 5 conditions that we're going to use in this class to tell if if two graphs are not isomorphic, and that's it. All right, so let's look at a couple examples. Let's first look at G and H here. Now let's see. Are these two isomorphic? No, they're not. They fail condition 4. You can see condition 4 right up there. G and H have cycles of different lengths. So in G, here's a cycle of length 3. But notice that in H, there are no cycles of length 3, right? In H, the cycles have length 4. 1, 2, 3, 4. So that's a 4 cycle. And then also this one. 1, 2, 3, 4, 5. Okay, that one's a cycle of length 5. Okay, so we have a 4 cycle and a 5 cycle in H, but in G we only have 3 cycles. We only have cycles of length 3. So this is why they're not isomorphic. If they were isomorphic, then G would have to have a cycle of length 5 and a cycle of length 4, and H would have to have a cycle of length and 2 cycles of length 3. Because you can see there's 2 cycles of length 3 in G. But because H has no cycles of length 3, immediately we know, because G has 2 cycles of length 3 and H has no cycles of length 3, we immediately know that they're not isomorphic. Moving down here. Now this may be hard to tell at first sight, but we can unwind G and make it look like this. And we can unwind H to make it look like this. And now notice that G has only 1 connected component and H has 2. So there immediately we know from rule 5, from condition 5 up here, if they don't have the same number of connected components, then they're not isomorphic.